Question 2, using the formula again, we're given that the probability of C is 0.55, probability of D is 0.65, and the probability of the intersection is 0.4. So if you add those two together, what we've got 1.2, take away 0.4, so we've got 0.8 for the total here. Now let's put this in the Venn diagram. I've got 0.4 in the middle there. I can have 0.25 here and 0.15 there. Just check that adds up. It does. So we've got 0.2 around the outside because we had 0.8 in the total. And now we're ready for all the questions. Part A, find the union. That's 0.8 already. Draw the Venn diagram. And the question here, the intersection of not in C and not in D. So that's just the bit around the outside. That's 0.2. The probability of being in C given that you're in D. So we're in the circle D. So that's out of the 0.65. We want to be in circle C as well, so that's that bit there. So that's 40 out of the 65, or cancel that down, 8 over 13. What have we got now? The probability of C given that we're not in D. So not in D are these two here, so that's 0.35. And the probability that we're in circle C, so I've got 1/5 there. So cancel that down, I've got 3/7 there, haven't we? Explain why they're not statistically independent. Well, basically because these two things are different. If they were independent, we've had lots of ways of checking that, but the one we're looking for here is that the probability of C is equal to the probability of C given D is equal to the probability of C given not D. Basically, whether or not D happens doesn't change your effect, doesn't change your probability of C. The fact that these two are different means that they're not statistically independent. You can always check that with the standard way, of course, that if we times the two things together, if we times those two things together, the 0.55 times by the 0.65, of course that does not give the 0.4 in the middle.